Well, greetings, mathletes, and welcome back. Today we're going to be talking about error, and more particularly, the point of today's lecture is to be able to tell when someone's estimate is a good estimate, right? And you can tell that by how much of an error they've made. And the error is the difference between the value you've estimated and the actual value that you find once you do the measurement. So, without further ado, let's go ahead and get started on this. Okay, so there's certain variables that we're going to be using in these computations. So we need to know what all the pieces mean to understand the formulas. So um, the first thing that we want to take a look at, and that's not a square root of e. That is my own handwriting. I always put a little tag on that on a v. That is a v with a subscript of e. I suppose that looks a little bit better, but this is how I make my v's. So but that's what it is. That's a v with a subscript of e, and that represents the estimated value. Then there's also just a v, and so this is actually your measured value, right? So whenever we're talking about making an estimate, it's kind of like making a prediction. We have a test coming up. I think on the next test, the students are going to average 72%. So that's the prediction. That's your estimate. That would be my VE. And then when the actual average comes in, after all the students take their test and it's averaged out, we get to see what the actual average is. Basically, what we're doing is we're seeing how far off we are from, how far off is the estimate from the actual value. And when you want to see how far apart two numbers are, one of the ways you do it is to just subtract the two values, right? So VE minus V would tell me how far apart the estimate and the actual value are. Now, when we're talking about error, we don't usually talk about negative error. Error is an overall absolute positive number generally, or it's a zero. So to guarantee that that happens, what we do is we put the absolute value on this. And so when we talk about this quantity right here, this is called absolute error. And I believe your book abbreviates it by writing AE, right? So that's your absolute error. So this is your formula for absolute error. Absolute error is the absolute value of the difference between the estimate and the measured value. Okay, so that's the first thing here. So let's actually kind of think about a what if here. Let's use the example that I had already brought up, estimating test scores. I've given exams for a long time. I usually have a ballpark feel for how a class is going to do on an exam, and so quite often I kind of make estimates to see and just kind of see how close my estimates are. So let's go ahead and take a look at how that pans out. Let's suppose a week before the exam, I think to myself, you know what? I think the students are going to score a 72%, right? And when I average all my classes, it's going to be a 72 on this first exam. Then we go ahead and take the exam, and I am pleasantly surprised and wrong because I find out that the actual class average is 78%, right? So it's higher than I expected, which does happen from time to time, and I am always super stoked about it. So now, since this is our estimated value, this would be our VE. Since this is our actual value, that's just V. So we have values for both of these things. If we go ahead and just look at how to compute the absolute error here, this is basically how far off your estimate was. It would be 72, right? That's VE minus V. Oh, I'm supposed to put a value in here. right? And then I'm going to take the absolute value of that quantity. Now, the way absolute values compute, you have to do all of the operations inside the absolute value first. You can't take this and turn it positive, right? You're gonna have problems if you do that. You're not getting an error then, you're getting something else. But 72 minus 78 needs to happen first. And so that gives me -6. And I'm taking the absolute value, and the absolute value is like Oprah. It just kind of goes through and makes everything positive. So my absolute error is the absolute value of -6, which is 6. And so that's the raw score, right? That's the raw error. It hasn't been touched, it hasn't been scaled down, or anything else. That's your absolute error. And so that's one of the things that you're going to need to compute. Wow. Um, in any case, it really is. It's just the distance on the number line between what you thought was going to happen and what actually happened, right? You're just measuring that distance between them is all you're actually doing. So, okay, so that's our first example. And let's see here. Yeah, let's go ahead and just get all of it and delete that. And we will go into the next example now. Okay, so the next thing that we're going to take a look at is relative error. Now, in math, whenever you say things like relative, we're usually talking about some kind of comparison by division, right? So, once you get into statistics, especially, you'll be talking about things like relative frequency, things like that. Basically, what that's doing is taking an amount and comparing it with the whole body you're measuring by division. Relative error is the same thing, and the thing we're going to be comparing it to is the actual value. So it's how big is the error compared to the actual value? So that's the question that we're actually asking ourselves. How big is the error compared to the actual value or the measured value? Right? So we're comparing these things. Now, if we remember from before, our absolute error was the absolute value of 72 minus 78. Oops. There we go. Which was 6. So what that means is we're comparing the absolute error to the actual value. And remember what the symbols for all these things are. The estimated value is VE. The actual value is just V. And so if we want to find the relative error, which your book is using RE to symbolize, what it is the absolute error divided by the actual measured value. Okay, so in this particular case, we are comparing 6 with 78, which was the value that we measured. So 6 was our error, 78 was the value we measured. Now, if we want to go ahead and, a fraction is fine to consider that a relative error, but there it is. Looking for my calculator here. If we just go ahead and do the division, oops, we get that our error as a yeah, I did that right. Our error as a decimal is 0.07, and I'm going to write out a few extra decimal points here. 76. Actually, that's a 9. There we go, and it keeps on going from there. Typically, when it comes to absolute error, it really does depend on what you're dealing with, but we can go ahead and round this thing to 0.077, or 0.07 or 0.08, excuse me. I believe that your book and your homework is having you do it to 2 decimal places. So that's a good way to go there. So we have relative error here. And relative error is the absolute error divided by the measured value. I want to point this out too. So I'm going to write this. RE is AE divided by V, but AE has a formula also. So we can write the whole thing out as a single formula. In fact, I'm going to put it on the next line here. We can write RE, and since AE has a formula, I can put in that formula, VE minus V. So I'm taking the absolute value of VE minus V, and I'm dividing that by V. Right? So that's actually the formula that we're dealing with. Now, if, and I'm going to get rid of some of this here. Actually, let me just rewrite this whole thing. Right, if I look at that formula, what this is giving me is a decimal. And so just like in the last lecture, there's also a percent error. And percent error is just taking the relative error and moving the decimal 2 places. So the percent error is the relative error times 100. Or if you want to write out the entire formula, PE is equal to VE minus V over V times 100, right? But you notice these are all the same computation. Each previous computation is part of the next one, right? So to find the relative error, you need the absolute error, and to find the percent error, you need the relative error. So they're all kind of connected here, right? So in this case here, if I wanted the PE, depending on where I'm rounding it, I'm either going to have 7.7% or 8%, depending on how I round it, right? So one of those two things. Now, here's the other question, is this a good estimate, right? Well, there's a rule of thumb for that. And let's see here. Let me go ahead and erase some of this. There we go. So here's the rule of thumb for telling if something is a good estimate. So the rule of thumb for estimates. If the percent error is less than 5%, then the estimate is considered good, or a reasonable estimate anyways, right? There are certainly cases where the tolerance is very, very low, like it's not a good estimate unless it's within 1% or 0.5% or something like that. But just for overall purposes, most of the time this is a typical good rule of thumb. Okay. So we've looked through each one of these things. We looked at absolute error, which is just how far off your estimate is as an overall number. Relative error, which is taking your estimate, your overall estimate, and comparing it to the size of the actual value, and you're comparing by division, right? And so that gives you that will give you the relative error. We're taking the actual error and comparing it with the actual value, or excuse me, the absolute error and comparing it with the actual value. And then percent error is just taking the relative error and multiplying it by 100, right? So each one builds on itself. Okay, so let's see if we can put all of this stuff together. Let's go ahead and Go ahead and erase that, and we'll look at another problem here. Okay, so let's go ahead and take a look at this problem. Gio's hearing some funny cars, some funny cars. Gio is hearing some funny noises from his car. Perhaps it's filled with clowns. I don't know. He takes it to the mechanic, and after doing an inspection, the mechanic estimates that the repairs are going to come to $835. After the repairs are completed, Gio received a bill for $891 in repairs. So, what's the percent error of the mechanic's estimate, and was it a good estimate? Right? That this is a perfectly reasonable thing to wonder if you've been given a good estimate. And actually, there are actually legal requirements on how far off a mechanic's estimate could be, or any contractor or anything like that. So it's good to know. It's good to know how to do this, because if you know what the limits are on how far they're allowed to be off, you can actually demand a lower price. So, in any case, let's take a look at this. So the first question we're being asked is, what's the percent error? So the percent error was the relative error multiplied by 100, but we don't know the relative error yet. We remember that the relative error was the absolute error divided by the measured value, right? So we can go all the way back there. So we need the absolute error first if we're going to attack this thing. So let's see here. We got the absolute error is just going to be VE, the absolute value of VE minus V. And so let's go ahead and consult the magic box. We'll just go ahead and subtract those two numbers. So we have 835 minus 891. So I'm actually going to write that down so we can see the computation. I keep doing that. Okay, and if we go ahead and compute that, that ends up being the absolute value of negative 56, which is 56. So 56 is our absolute error. It's off. The estimate was off by $56, right? We can even put the dollars in if we want to remember what we're looking at here. Then we need the relative error. And the relative error, but we can go through and write the whole thing down, but we're actually finding this stuff as we go. This is the formula for the relative error. We've actually already computed the numerator of this. We know it's 56. And the actual value was $891. So we need to take that, 56 divided by 891. There we go. And that comes out to 0.06285, blah, 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 blah. That's going to keep going like that. So we're going to go ahead and just let's go ahead and round it to 3 places for right now. So this is going to be 0.063, right? So that is our relative error. Now, what it's asking for, though, is the percent error. And the percent error is just, if we write the whole thing out, it's the relative error times 100. And since we already know what the relative error is, this whole first part is already computed. So we can just think of it this way, right? The relative error is 0.063 times 100 is going to be 6.3%. Okay, so the percent error of the mechanic's estimate is 6.3%. Our rule of thumb says anything, a good estimate is less than 5% off. This is 6.3% off. So this would not be considered a good estimate. 6.3 is greater than 5. Not a good estimate. Right? And so this is how we're going to walk through and do these things. I forget what the actual percentage is for mechanics I think mechanics and contractors have the same limitations. It's something like they're not allowed to have their estimates be any more than 10% off or something like that. Um, so if you do know that percentage, you have grounds if they go over that. And now you actually know how to compute their percent error so you can check it. Okay, so let's go ahead and clear this off. And I think this is about the end of what I wanted to cover here. So, um, what the main thing we want from today is being able to compute absolute percent, absolute relative and percent errors, right? Remember that a relative or a percent error is always compared to the actual value. It's not compared to the estimated value. It's compared to the actual value, the measured value. It's probably one of the bigger mistakes is dividing by the wrong number. Other than that, we should be good from here. Make sure you contact me if you have any issues, and I will see you guys in the next lecture.